All right, so we're going to be talking about exponential functions and what they look like on the graph. So exponential functions are something that increase or decrease very rapidly. And so a lot of this is described, you have growth and decay models that you use this for. We're looking strictly at the graphs right now, and we'll look at the other ones a little bit later. So just to look at the graphs, kind of get a base feeling, we're going to look at these and kind of sort of talk about what this looks like. So the first one we have is y equals 3 raised to the x power. So that's your exponential function. And so on that, you're going to have we're going to look at the table and we'll graph these points. So if we start out at negative 3 raised to the negative 3 power, essentially, is what this looks like. This is going to be 0.04. That's kind of rounding. The next one is 0.11. The next one is 0.33. And then we come up with 1. So all of that raised to the anything raised to the 0 power is 1. And we can talk about that a little bit later about why that is. And then at 1, we're going to have 3 and then 9. So we can graph those points. So you can see that it's going to increase very slowly, and then it starts making some very big jumps. And so when you make your graph here, it's going to come down like this. Now it looks like it dropped all the way down to the x-axis, and it didn't. And to the naked eye, it's going to look like it. But as you zoom in a little bit closer, it never touches the x-axis. That's called an asymptote. And we're going to talk about that a little bit later as you come in to the math workshop. So this is called an asymptote. It will never reach that line. Now, why is that? Well, never can you raise something to a power and get 0. So that's kind of sort of where that's coming from. All right, so let's look at the next one here. We are going to have a negative out front. And so just like with quadratics, when you added that negative out front, it flipped it over the x-axis. It's going to happen the same thing. So instead of it growing exponentially, so it's getting very big very fast, it's actually going to get very small very fast. So just kind of sort of making sure that we're kind of on the same page. We're going to fill out the same table here and look at and see what that looks like. Okay, so as we look at this table, we have looks exactly the same. We have negative 0.04, and then negative 0.11, and then negative 0.33, and then negative 1. So again, the only thing that's happening is that they're going to have negatives instead of positives. So again, I'm going to get very, very close to the x-axis, never touching it. See here. So we have like something that's really close, a little bit further away. Ooh, sorry about that. Okay, here gets a little bit further away, and then we finally get up to 1, or negative 1, excuse me, and then negative 3, and then negative 9. And so as you move, if you want to look at this, you can see that by 7, you're at negative 2,187. So it grows very, 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 very fast. Or in this instance, it's actually going to decrease very fast. So here's my line. It's kind of hard to sometimes do. So it's going to make that little curve just like that. It looks like an asymptote to the right. Like it looks like it's never going to reach anything bigger, but it will still reach all those values. I'm trying to get this just right. Here we go. All right, so it looks like that, just a curve like that. So not a parabola, not a linear function. It's not linear, it doesn't make a line. It just kind of curves, and it's going to approach infinity as x gets bigger, but as x gets smaller, it's going to approach our asymptote of the x-axis. X equals 0 is that asymptote. Okay, so, or y equals 0 actually. That's that asymptote equation. All right, so that's exponential functions, just kind of getting used to them, getting used to kind of sort of how they grow, how they look, those asymptotes, what that looks like, and all the transformations that we learned with quadratic still apply for exponential functions. So, make sure you're going through this, paying close attention to the graphs, to the asymptote, and we'll see what this looks like next lesson in application problems.